Welcome back to yet another mastery learning session. So today we're gonna see another live Leetcode problem solving approach. So if you remember, we covered up to 28th problem. Today we're gonna go to the next one, which is 35th. So this is the problem statement says like it's a search insert position given an assorted array of distinct integers and a target value. Return the index if the target is found. Not return the index where it would be if it were inserted in the order. So you must write an algorithm with the order of log n runtime complexity. So here if you see 1, 3, 5, 6, expected target values of 5. The 5 is available at second index position. You can find that directly and you can return it. The second approach, the second example, nums 1, 3, 5, 6, when the target is 2. So if you observe, the 2 value is not available in these numbers. So you need to find, so where exactly this number 2 can be fit into this position, so that here it's like if you see, the 2 has to be fit between 1 and 3, which means like 0th index is 1 and 2 has to be here at position 1, so that 1, 2, 3, 5, 6 will be there. In example 3, nums 1, 3, 5, 6. So when it says like a target 7, you can see that the largest value is a 6. So the next element will be 7, so which is nothing but 0, 1, 2, 3, and the fourth position has to be filled with 7. So the output index value is 4. Well, so if your interviewer asks you to write an algorithm with the order of log n, and if you see that if you understand the pattern, it is nothing but it's a searching pattern and the data is assorted. In your mind, you always have to get an idea, which is nothing but binary search algorithm. So if the data is assorted and you have to find algorithm within log n, then always have to go to binary search algorithm. So okay, so if we ask this question, there's a two solutions. Currently in my mind it's spiking two solutions, one with order of n, which is a straightforward order of n approach, so you're pretty much aware of that. So you will search each index, each value which is a less than number, which is less than our target. If it is equals to target, then return it. So what we are doing here is like we keep on compare each numbers with our target. If the target is found, we will return. If any number which is a greater than target, then that is the position we have to fill. If we reach the length of end of the numbers, then we have to return n plus 1 is the position of the target. So if we write the three possible solutions here, if we try to start writing three possible solutions, one second. Okay, so let's write our first approach, which is order of n time complexity algorithm, where what we will do here is we will write a for loop. So we'll read one by one element. We'll keep on continue. If what we'll do here is we'll compare each index position, and if we find anywhere if index position is greater than our target, okay, so that's the position which we need to put that. So we'll keep it that int result equals to -1 initially. So result or the insert position, we can put a naming convention like this, insert position as a -1. So when we are reading, keep on reading it, if number of index, which means in this example you can see first we'll compare with the 1 is greater than 2, no, we'll go to the next one, 3 is greater than 2, that's the correct one. So we have to end our loop there and we return that value. So that's what our integer position which we take, and then we return it, or else otherwise we can do another approach. What we can do here is, so let's put this number here, okay, index position, okay, insert position, where we'll initialize with a 0. Let's write a while loop, okay, while insert position is less than number of length, okay. So in the loop we always keep on increase our insert position. When we are trying to search here, if number of insert, in the array, the insert position, which is that index position, is a greater than target, we just need to set a boolean flag. Let's take boolean flag is insert position found, okay. So let's put it initially it's a false, so I will put the condition here with it, okay. So when we get this one, we'll keep it that insert position as a true, okay. But observe here in the second case, 3 is greater than 2, so we'll get that insert position as a true, and but we are not breaking that loop, we keep continue that loop, so that insert position 5, again 5, the third element, if this is also greater than 2, and our insert position will be true, but our insert position index, which is keep on increasing it, so we need to break it. So we're gonna put a condition here, if I don't find insert position, then continue. If I find an if I find an insert position, then you don't need to continue, you don't need to look to further level, just return that insert position as a return value, that's it. So observe here, again this will break one case, I will come to that one where exactly it will fail, but let's see that one. So what we are trying to do here, so here in this case, if you see 1 we are comparing it, 3 we are comparing it, 1 is greater than 5, no, so we just increase that count, then now we will go to 3 is greater than 5, no, then it will go to 5 is greater than 5, no, then it will go to 6. So our condition has to go greater than or equals to. So when we compare, let's iterate one more time, 1 is greater than 5, no, 3 is greater than 5, no, 5 is greater than or equals to 5, yes, true, then we are keeping that flag is insert position found as a true, okay. So when we set that true and negation of true is a false, we break this loop and we return that insert position. So let's see the second example, 1 3 5 6. So again we'll compare 1 with 2, 1 is less than or equals to 2, 1 greater than or equals to 2, it's a false, so insert position goes to the next one. 3 greater than or equals to true, yes, So we found that insert position, which is nothing but insert position value, we return it. So let's see that the last edge case when the target is greater than the largest value. So if you see, again, we start at 0th index position. So 1 greater than or equals to 7, no. 3 greater than or equals to 7, no. 5 greater than or equals to 7, no. 6 greater than or equals to 7, no. But if you observe the first condition where insert position less than nums of length, this condition is a false. So our while loop break it, because we are keep on increasing that insert position. So we reached end of that array. So that's why it break there. So we get that result as insert position. Let's run the code and see the result. Something is wrong. Oh, it's a boolean. Sorry, I used C++ and C syntax, which is a bool, whereas in Java you have to use a boolean. Let's see. 1 3 5 6. So 0th position. Oh, see, we are, even though if we find this condition, we are keep on increasing that. So what we can do, if it is, let's put it this string in an else condition. Okay, so because we keep on increase that insert position when our data is not found. If the data is found, that is the position where we need to return. Okay, let's run the code and submit it. Let's see. Cool, you solve the problem, but if you observe, this is using the time complexity of order of n. But if you observe here, the interviewer asked especially write an algorithm with order of log n. As I mentioned previously, if the data is sorted and we are doing the search operation and you want to find the result in order of log n, then you have to use binary search algorithm. So if you are not familiar with the binary search algorithm is a pretty straightforward approach. So in a simple case, what is a binary search algorithm? Very simple. So if you have, like, let us assume rather than going with the numbers, let's go with a small, or let's go with the numbers. So assume you have a numbers of like 1 3 5 6 and maybe 7. So the binary search will tell you that you don't need to go one by one element, go fetch middle element and try to compare that middle element. So let us assume here we wanted to find 3. Okay, so if you want to find a 3, so if you give this problem to a small kid, what he will do, he will go, okay, he will check, okay, 1, and then he will check 3. Okay, I got the 3 here. So he will tell like, okay, 3 is available at index position 1, right? So let's put it in index positions here, 0 1 2 3 and 4. So now but if you give like a little bit like a 10 years kid, so if he gets like a little bit advanced, then he will think like, okay, why do I need to go search one by one? So let us assume we wanted to find 7 here, target is a 7. So if it gives to 7, the kid usually goes like 1 3 5 6 7. Okay, I found 7 here, like this, right? So but what does the binary search will tell, as it indicates by means like a make your array of and compare. So what you need to do, you know that this this array is a sorted order, which means your data will be in increasing pattern, which is like this, right? So it's gonna be go in an increasing pattern format. So you know that every I plus 1, every I plus 1 value which is always less than I plus 2. Remember this, every I minus 1 value is less than I, because this is the pattern of increasing order, right? So binary search will tell you, find the middle element first, check if the middle element is equal to your target, return it. If it is not, then compare your middle element. So if it is not, use middle element to identify whether you have to search either first off or second off. Got it? So first check this middle element. Based on this middle element, if it is middle element is equal to your target value, return it. If it is not, go either of the direction. How you can go to either of the direction? Very simple. If your target value is less than your middle value, okay, then you have to go to this direction, right? If your target value is a greater than mid value, means like let us assume target is 7 here, 7 is greater than 5, so you know that 7 is always exist in the right side direction, so you have to go to this direction. That's it. So we have to use this binary algorithm to find corresponding index position. Okay, so now you can say that, okay, binary search algorithm basically we will use to find given element, right? How do I know that where, if the element is not exist, and where exactly I can find that corresponding position? If you observe here, so let us assume okay, so let's write an algorithm. I will tell you like what is the one scenario which will gives you more understanding. Very simple. Let me tell you this. So we'll do that 2 pointers. Okay, in the complete array, we'll binary search algorithm. We take 2 pointers. One pointer gives like initial position. Second pointer gives like a final position. Then we will find that middle element and all this operation. So let's do that binary operation. So when the left pointer crosses the right pointer, that is exactly the position where you will get your the corresponding index position. So usually here for the 2, your left pointer and right pointer crosses at here, like that. So what we'll do, we'll write a simple algorithm, order of log n approach. Okay, so I'm gonna comment this code for your understanding purpose. Now what we'll do, we'll write a very simple problem here. I'm gonna take int start position, okay, where it is 0 initially, int end position, where I'm gonna take nums dot length, okay, or length -1, or yeah, either of them you can take. So I will put while start is the less than equals to end. Okay, I'm gonna make it until they both cross. So I'm gonna find int mid equals to my start plus end by 2. And remember, this is not the proper way. Here there is a chance of integer out of bound exception. Sorry, integer out of bound exception can occur, so you have to use another format. So we'll discuss that later, but let's go to this one now. If nums of mid, okay, if nums of mid equals to our target, we'll just return that, return mid position. That is the where your target is there. If it is not, okay, here comes to our logical pattern where we need to go to which direction, whether you have to go to left side direction or right side direction. We'll find here, if nums of mid, let's use the same pattern, okay, if the target, so which is our target value, if our target is less than our nums of mid. Okay, then we have to search this pattern, right? Like the first array. So if you observe here, the start is 0, it is always there. For the end pointer, you have to make your mid -1. So what you need to do here is you make end equals to mid -1. Else, if it is not that case, you have to make start pointer, because you have to go to the right side pointer, right? Like, I mean, you have to go to this direction. So your start equals to mid +1. The condition where these two sections will cross, that is the where, I mean, if the number is not available, so your both pointers will go, and they both cross exactly the position where, I mean, like here in this case too, so the start pointer and pointer keep on comes here, they will cross here. So that is the position where the target is there. So let's try. I mean, let's see that what is the expected result. So we found this number. Let's try the second one, where the same one with 2. Let's run the code, observe the result. Cool. Let's try the third case, 7. Run the code. So this is what the code. We are using order of log n rather than keep on searching in a while loop. So let's run this code, submit it. Oh, my battery got drained. I mean, my laptop getting drained. See, cool. Your results also accepted, but now this time it is order of log n. Thank you for today, class. I will take another session on next